Right, the 2014 school geometry exam, question 3. AE bisects angle BAD. Now bisects means cut in half, so the other part of that must also be 36, even if it doesn't look like it. Triangle CDE is isosceles. Well, I can see that, which automatically makes that 64 as well. Find the size of angle ABD. ABD. Oh, so we're looking for X. Alright, well if that's 64, then that must be 64 because they're vertically opposite. And then we can do 180 minus those two angles, which would make that 80. So that means angle ACB, which is not staying tonight. It's vertically opposite angles are equal, and therefore angle X, which is ABD, equals 80, and that's because of angles in a triangle sum 180. Right, now I don't want to lose the diagram, so you can read ahead and look at part 2. It says to find the size of angle ADE. So let's have a look up here. ADE, that's that one in there. Right, so we know that that's 64, even if it's not going to stay there. So isosceles triangle, 180 minus 2 lots of 64 makes that 52. And angles in a triangle, now that we've found this one is 80, 36, and that's 36. So that whole angle there is 72, and an 80 would make this bit 28. And then adding the two together makes an angle of 80. So we need to start by finding angle EDC. Perhaps we need to explain CED. We should probably explain putting it all in, and I'm not probably going to have enough room. CED. Now we can do angle EDC. Right, and then we need to say BDA. For that one. And then of course, so angle ADE equals 28 plus 52, which equals 80 degrees. Right. Now the next part of the question, of course, refers to this diagram. Oops. So I'm just worried that the diagram is not quite big enough to answer the next part of the question. Now the diagram has lengths to it for part C. It says AB is 6 centimetres, BC is 4 centimetres, and AD is 4 centimetres. The question says find the length of ED. ED. So if we find a highlighter, it's this ED that we want. Now to find lengths, if you don't have right angled triangles to be able to use Pythagoras and SOHCAHTOA, then you need to be considering similar triangles, using similar triangles. So we need two triangles in there with the same angles in them. So I can see there's this one with a 36, 64 and an 80. And inside here we have 36, 64, and the one we've just found in here, of course, was the 80. So just to help us with that, we erase those two, and I write that back as 80, We colour in the 80 over here. The 36 we'll call our double angle, which is the same as this 36 here. And then I can see there's a 64 here and a 64 there. So they're similar triangles actually. So we could say that triangle ABC is similar, and of course this is answering part 3 on the next page. Triangle ABC is similar to triangle ADE. Okay, because they have the same angles in them. So now we need to find some corresponding sides. So I can see that side AB goes between the 80 and the 36, which is the same as this side here between the 80 and the 36 on the other triangle. So that means side AB corresponds to side AD. That one corresponds to that one. So there are many ways to do similar triangles. So 6 corresponds with 4 in the same way that this side corresponds. Now that's between the 80 and the 64. So over here, and between the 80 and the 64 is actually side ED, which is the one we're looking for, this one here, side ED. So the top number is the side from the original triangle. Comparing that with the corresponding side on the image triangle. This side on the original triangle between the 80 and the 64 corresponds to this side on the other side. So here's my little equation. I'm going to use some cross multiplying. So 6 times that side equals 16. 4 times 4 is 16. Dividing by 6, ED must equal 16 divided by 6, which is 2 2/3. Alright, it's quite hard. It's quite hard to pick the similar triangles within those two. There are other ways to do it as well. So that was actually part 3. Right, if we're looking at B, we've got a circle geometry question. It's not a very difficult one. Find the size of angle X. Well, I can see that that must be 16 as well, because there's my butterfly, and these two angles are at the circumference, so that's angle QPT. Right, and now we can use angles in a triangle to find angle X. Done. Right, we're told that AD equals DC, so those are the same size. The other interesting thing is that there's two radiuses here, so they must be the same size as well, although not necessarily as the ones below, but it does make for a symmetrical quadrilateral in there. Find the size of angle ECD, so it's that angle we're looking for eventually. Right, there's my arrowhead, so that must be 2W, oops, 2W, because of the arrowhead. If that's 2W, then this one around the outside must be 360 minus 2W, and then this is the one at the circumference that would be half of that, so that would be 180 minus W, and we've got that one. And because the sides are the same size, then it's symmetrical, and those two angles must in fact be the same. Right, so let's start with AEC. Right, and then that means that angle there, AEC. Right, so I've got two AEC. So the first one is an obtuse angle. The next one, the AEC, is a reflex angle. That's using angles at a point. And that one there, ADC, it's going to be half of that. Once again, angle at centre. Right. Since AD equals DC and AE equals EC, then angle DAE must equal angle DCE. So to find angle DCE, ECD, which is what we're looking for, it's going to be 360 minus 2W minus 180 minus W, and of course we'll need to divide all of that by 2 once we've worked it out. .360 minus 180 minus 2W, two negatives make a positive W, so I've got minus 2W plus 1. We want to divide that by 2. 180 divided by 2 is 90 minus W divided by 2. And we also used angles in the quad sum 360.